When living things unintentionally become part of an electric circuit, in most cases, bad things happen. Here's a brief anatomy of an electric shock. The human body provides protection from electricity, but that protection is limited. The first line of defense is our skin. Let's return to the concept of resistance for a minute. Skin has high resistance to shock. Recall that resistance is measured in ohms, and dry, unbroken skin can have up to 50,000 ohms in resistance. But inside the body, which is more than 70% water, this resistance drops drastically to only 300 to 500 ohms. To measure the effect on the body, let's take common household voltage, 120 volts, and divide it by a resistance factor of 40,000 ohms, typical for human skin. The result of voltage divided by resistance is amperes, the amount of current which is flowing. Only here, the amount is so small, only 3/1000ths of an ampere, that it's termed a milliamp. Let's see how different current levels affect the body. Up to 1 milliamp of current produces a slight tingling sensation. A mild shock is felt up to 10 milliamps. Moving up to 25 produces a painful shock and muscular contractions. Over 25 will produce severe muscular spasms. And once a level of 50 is reached, ventricular fibrillation, which is irregular heartbeats, results. When a level of over 200 milliamps is reached, severe burning will take place. If sustained, because the body is mostly water and blood is fluid, it will actually boil at some point. Unfortunately, as voltage increases, the skin's ability to resist it decreases rapidly, and the outer layer can break down, so protection from current deteriorates even more. Other factors influence the severity of damage from an electric shock: duration, path through the body, and skin moisture. The first variable is duration. If a shock is brief, it may only be painful, but if sustained even at low current levels, it can cause irregular heartbeat or death. 100 milliamps with a duration of a few seconds could be fatal. And consider this: a small electric drill draws about 30 times as much current. Likewise, very high current entering the body for only a moment may not cause death, but any sustained exposure almost certainly will. The second factor is path. Which area of the body did the current pass through? If it traveled through the torso, the heart and lungs may be affected and stop functioning. If the path didn't go through the torso but through a limb, severe burn damage is a strong possibility, both inside and out. Any moisture on the skin drastically reduces resistance. And another deadly aspect of wetness is surface area. The more area in contact, the lower the resistance.